So here with Bruce Sizemore, the brains behind the More Golf brand. So it might not be a company that many people have heard of too much, but there's some, I think, really exciting developments in science and design and physics that aren't necessarily used in the rest of the golf industry. So a little bit about kind of, it's been, you said about 5 years or so in development.
Yes, sir.
The company's been in I mean, we certainly first talked about 18 months ago, I think it was.
Sure.
So what's obviously frustration with other products not doing what they could do, but what started this off?
Yeah, so my background is first as a professional golf instructor. I turned pro when I was 19, and with the goal of playing on tour, and then I became a professional player on tour. Unfortunately, my back didn't agree with me after around 27, and I'd always studied golf clubs and shaped my own stuff and gone deeper, built all my own stuff. But so I had ideas, and I thought, okay, hey, listen, this is a perfect time to use my background in giving thousands of golf lessons and playing thousands of competitive rounds of golf, and start looking at my first couple of lines were billet milled, American made putter lines. And I thought, I've been there, done that, and the putters all had modularity to them. First one to kind of have interchangeable alignment pockets and things like that. And I thought, hey, if I take that same approach to potentially to irons, wedges, and then maybe even the hybrids and fairways, let's see where we can go, because the CNC billet machining process is such that we can do such micro precision tolerances, and I thought it is possible. So what I ended up doing then is looking at every category, whether it be a putter, a wedge, an iron, soon to be our hybrid and driver lines coming out, is just to isolate the faceplate. So look at the faceplate for what it's asked to do and its applied application, and then blow apart all the components. So I just have a standard cast forged type of one-piece golf club head, and some of the inherent properties that never really made sense that we've all kind of known, right, is that the center line of the hosel exits outside the playing surface. And now you have a hosel area here that weighs around 70 grams. So if you take that hosel that's cut off of there, and then you put ours in your other hand, one is nearly weightless, and the other one has 70 grams. So what we were able to do is to take that.
It's always funny when you isolate the bit. It's like when you pick up a club head for the first time. You go, "Wow, it's heavy." It's
a dramatic. It's a great thing for people to feel the weight difference, right? So we were able then to take the 60 grams out of the hosel, and put it into the head. Mass behind, the center mass of the golf club head. More mass equals greater transfer of energy, which means greater ball speed and so forth and so on. So the challenge was, okay, if we isolate the faceplate, then we explode the hosel off of it and the flange profile off of it, we can do a couple of things. So it was all a mass and geometry game, more or less. So it was how can we change the mass properties of a golf club radically, and how can then we take advantage of that new geometry too with billet milling, that we're allowed to move parts kind of where we want. So
I guess the problem is the complexity of making a head that shape in one piece versus, as you said, if you can isolate the various component parts of the key parts of the head, actually, I guess the fundamental is, does that allow you to make a more efficient, better designed head? Oh yeah,
the stability is amazing, right? So it wasn't only taking 60 grams out of the hosel and putting into the head, but it was also repositioning it from a geometry standpoint. So our hosels we moved it up and we moved it in. So the center line of our hosel now exits right here in the playing surface. So if you noticed on this one here, any other conventional iron wedge, it exits outside the playing surface, and you have all this swinging gate mass and geometry. So what you basically have on this now is basically a near center shafted, target balanced, the most stable head in golf. It just where you set it at address is just where it wants to return.
I think this is the thing, that's something that we all know in industry. We've known for a long time because it happens with putters. It's not a new it's not a new bit of
It's not a new thought that
tech,
we've
it's
had
not a new
rolling around in our
concept,
head, but
yeah.
how do we accomplish it? So it was impossible to accomplish it in a casting or forging one-piece matter. It had to be blown apart into its main components. Now, when we get into the flanges, then on our irons, we have two current different styles of flanges: our tour flange and our mid flange. On our wedges, we have 6 different types of flanges.
Yeah.
So the concept of now blowing the flange sole profile off and putting it back together is now you can have different sole widths, different camber and radius, different heel and toe relief, as opposed to our mid flange here. And then we have our tour flange, which has a thinner or narrower sole profile. It also has less kind of effective bounce profile on the bottom. So the tour flange might be for somebody that delivers the club a little bit more shallow, may want to work the ball a little bit more, where the mid flange is just kind of a all in. Once we shaped this and all got it right, it just provides amazing turf interaction. You know, it just kind of glides effortless through, but also with the fact that, you know, again, taking all the weight out of the hosel, moving it up and in. The head stability is just the club face just wants to stay square to your swing plane and then return square at the bottom. So you now, with these clubs, can fully release the club at the bottom without fear of looking up and thinking, oh boy, that's left. So it has a lot of performance and playability advantages that come through, you know, as you know, the players started experiencing them. That's why we kind of came up with the phrase, just swing it, you will experience a difference. We have a lot of our customers that come back to us and call and say, did you know your clubs do this? And then, did you know they also do this? And we're like, yeah, but we're already kind of have a learning knowledge curve built up. So, but we love when our customers come back and say, wow, these clubs do so much more than my kind of traditionally designed golf club.
That's certainly what we've noticed with the testing the clubs we've got in the studio is the ball speed consistency. Again, going back to the amount of mass distributed at the contact point, but the strength of flight, you know, represent relative ball speed, but the dispersional consistency very high.
That's the number one thing, right? And you guys are amazing at what you do, at Precision Golf, and so we're very happy to be, you know, in your location, and so you just kind of hit the nail on the head, right? Shot dispersion goes from here to here, and distance control is just shrunk too. So all of our clubs, really, whether it's our putter line, a wedge line, our iron line, soon to be metal line, is about shrinking the circle. Paying attention to what that club in that club category is what you want to do from it optimally, and allow it to be something that, you know, also fitters like yourself can look at someone's swing profile, match your club more in depth to how they deliver the club to the ball. That's the important part, and then that golfer goes away more educated, more in tune with what they're doing here and what's happening out here, gives them more confidence, and we all know at some level, confidence plays a big role in the score at the end of 18 holes.
And from a tooling and a machining point of view, is this something that's only really been doable very recently from a materials to be able to get, for example, the hosel light enough to make this actually happen? I'm glad you asked that. I don't get answered that. This is this is a super alloy that's proprietary to us. Right.
It has a pretty high level of scandium in it, but it has a ductility bending point to it, but it always comes back to its original shape. We chose to use 303 stainless, raw 303. This is not coated, it's not plated, so you're not starting out with like a carbon steel and then putting a chrome or hard nickel coating over it. So 303 stainless, as you know, is the preferred metal for premium billet milled putters, Cameron, Bettinardi, ours, that type of thing. So you're getting that true substrate and that soft feel. So, you know, a lot of times people, they're like, wow, all that connection, and is this going to sound funny? And then they hit it and they're like, that is the most purest sound.
Yeah.
I liken it back because I'm a little more advanced in age than you are. Back in my playing days, when we were playing like the Titleist 384 Balada, right? And that sound, that just mellow click.
I only got about 2 shots out of each one.
Crashy, not too thuddy, just that awesome sound.
Yeah.
And people, and I know that because guys that I used to play with that are now in the Champions Tour are like, this will say the same thing.
Yeah.
I remember this. I remember the sound that I'm hearing. So yeah, there's all different types of technologies and layers of that that then bore out new performance and playability advantages that's just never been possible in a traditionally designed and manufactured golf club.
I think that's the thing that struck me the first time I saw this, and we first talked about it. It's was that this is an engineered golf club. It's not a. I'm not going to say it's not designed because it's clearly a design product. It's not just an aesthetically designed product that's the norm. That's we're just used to seeing products of that kind of shape and form, and therefore, well, we might as well keep that because it's what people are used to seeing. It's something that, and I like the I guess radical nature of it, and say, okay, well, how do we, you say, blow it apart, pull it back together, and from a functional point of view, what works best? And obviously, you've got the milling patterns that you've got on the face, totally different than anything else out there as well. And going into that, it's a sort of crisscross, multi-directional mill, and just down to those sort of details. What is that really? What is that achieving more than the traditional kind of straight across groove? What functionally, what does that do as well?
Sure. So in the iron category, it was mostly just we want to shrink dispersion and distance, distance control. And again, with, as we said, taking all that mass, just going back to this really quick, taking all that mass out of the neck and putting it into the head and creating such an amazingly stable head. What that also allows, though, is that traditional sweet spot, which used to be kind of low towards the heel, now is perfectly centered. Yep. Now we have a very high vertical CG on the original Mod 1 irons because we wanted more of that penetrating, boring
so
flight.
It's got a strong fly to that original Mod.
Yeah, and I'll get to our Mod Plus, which is going to be coming out next, which shares all the componentry that can match back up with it, but was designed solely to lower that CG so that the player in their maybe 4 or 5, 6 iron might want a little bit of a higher launch angle, spin rate, peak height, sharper descent angle. So we'll inevitably, and there's 2 other faceplate models that will all match with the same flange and hosels, so that you as a fitter and your staff now can put together a blended combo set, unlike never, literally say, okay, we're going to fit you into the 4, 5, 6 in the Mod Plus with the Tour flange because you're a little shallow and want to work it. Then 7, 8, 9, 10, we're going to leave you in the Mod 1 because you want it more here to match your window, so that all your 4, 5, 6, 7, 8, 9 are just have that same window and the same dispersion tightness. So
I think because of the nature of the mass that's in the faceplate, you can more accurately move the CG around because you're not having to worry about so much weight in the hosel, so you can be that much more definite about
and
where
then you can literally hit it low off the heel, dead center, high off the toe, and I know you guys have experienced this, right? And then normally you hit it high off the toe and you don't want to look up, especially on the golf course, and you're like, oh, that's even going to be short of the bunker, right? And then you look up and it's like, whoa, it's just on the right side of the green. So we like to say it's our sweet zone because you literally can hit it almost anywhere on the face and it's still straight, and more importantly, the distance control is still that tight.
I think to kind of explain a little bit about why that's the case is with the hosel being in and forward, what you don't get is the twisting on an off-center hit. The momentum. You're not going to get that kind of same kind of gearing effect because the mass is in the head. It stays with it. Say like people talk about kind of center shaft or face balance putter. Once you lose that twisting, you lose a lot of the energy loss. So it all goes through into the ball and keeps the distance.
And then I apologize. Getting back to your original question on what we call our peak spin technology. So we came up with this really exotic machining method. Only a dumb golf pro like myself could come up with, right? Because if you look
at
our,
a dumb one could.
If you look at our tooling and how we go about this, it's bizarre, right? And it was trial and error, literally a couple hundred times before I'm like, ooh, I'm getting something I like. So the reason that we do what you were talking about is that surface friction that we're trying to create, coefficient of friction on the face, so that we all know that spin profile comes off that top groove of the top corner of that groove to on a full shot. When you're getting 10,000 RPM on a full wedge shot, and that's fine, right? But then all of a sudden you have that 50-yard pitch shot, that half swing 50-yard pitch shot, and you see your numbers drop down to like 3,000 RPM. It's because the ball is not in groove, engaging in the groove profile as much. So now you have to rely on surface friction. So what this does is it provides that extra second step on those half shots to keep your spin rates almost equal to your full shot. We don't need typically more spin on a full shot. Where we need it is on those quarter shots, half shots, and things like that. So again, consistency. So having consistent spin rates, not just on full shots, but as you back down to a 3/4 to a half swing type of thing. Again, we're all about consistency and shrinking that circle.
And so with the iron face, the wedge face, different depth and slightly different angles, or the same kind of pattern of mill, but a different depth.
On the irons, it was way too much.
Yeah.
It was they were way too spinny. And even we have a groove profile even for some of our tour players that really spin it. And even on the half ones, we were working with one of our tour players just a couple of weeks ago, and he was spinning at 8,000 RPM on a 55 yard, just soft, neutral shaft angle, just in the center, just kind of going after it. It's just like a normal, just soft pitch shot in. And
it's about 1,000 revs more than you'd normally get.
And I was like, okay, we'll give you a little wider or more angle on the exiting portion of your groove, because it was actually a little too spinny. Now, you're not going to find your recreational golfer ever complaining about that, right?
So they're happy when it backs up fine, 15 foot short of the pin. It's great, it's amazing. I mean, fantastic. It's such a great explanation. It's so nice to be able to get that from you to explain to everyone to see kind of why the product is as it is. And with the I'm going to get the name wrong. The new face there, the different one. Is that something that's going to be how soon are we looking at that being available?
I just realized I wrote on it here, but so this is already ready to go, and we're going to start actually when we get back to Michigan. All of our clubs are designed, engineered, billet machined, all in Jackson, Michigan. So everything's under one roof. Even our assembly, which makes it every person has something to look after. But with the Mod Plus irons now, you'll see it's a little bit more of a cavity back feature.
I'll show the back on that as well, so you've got the two. So that one where the CG's brought up there and the higher center of gravity line versus this one a little bit deeper down the bottom.
And so what we have here that's unique, outside of the cavity feature, which really doesn't do much, but what we've done here, this center weight port will allow fitters, teachers to interchange. For our standard is six grams. Our lighter one is 4 grams, and our heavier one is 10. So you can go standard -4, +4 grams, so that if you're fitting different shaft weight, length for sure, grip weight, and you can dial in now closer to in that set swing weights that are consistent. And then the most important thing then was this tungsten piece here. That's what really moves, So, and excuse me. The convenient part of it is that it's just right behind the flange, but you get that kind of cool reveal on the bottom that lets you know, okay, it's there. And this is the one when it's in your bag, right? This is one that's gonna launch a little higher in that 4-iron that I kind of want coming on that descent angle coming down. So the ability again to interchange standard or 2-degree flat hosels, interchange flanges, and faceplate styles with different flighting characteristics. It's just fun to work with.
That's the thing, particularly with the UK, because the wedges with the different, the ability to change the flange out only have that change, where we have such different conditions from summer to winter. Winter we have soft fairways and rock, no sand bunkers. Summer it's rock hard fairways, soft sand and bunkers. So to be able to interchange that out and have that ability to tune that in to the conditions you're playing, the time of year, the player, that gives the player a lot of versatility in how they set the bag up. Course conditions, time of year. So that's so versatile, which is great.
And then in our wedges, as you guys know, right, there's 6 different wedges, 6 different profiles, but also in that down or up position, so that you can, in the up position, it's taking out around 4 degrees of effective bounce profile, so to speak. But we always look at it in 3 planes, right? The first third when you have a little bit forward shaft lean, the second third when you have neutral, shaft position, and the third when you have negative shaft lean. Is there a third? I'm not sure about that.
That's all right.
And then we literally, when we were coming down for this show, we were kind of thinking, we chose to drove down because it's kind of our think tank also, and we thought of this super cool way of kind of getting a tuck and roll type of profile to the bottom that will be, it's solidly locked in up here. So and that's the fun part though, right? That's literally kind of the magic for us at More Golf in our design team, is to have a canvas now that's modular. Our clips are modular in design, so it's not limited. We're not limited anymore to one style of a manufacturing process. With the billet machined characteristics of it, it's endless. I mean, we're literally just at the tip of where we are. The best is yet to come, and we have the ability then to learn from our fitters, our premium fitters and teachers, and their golfers, their students, as to what's most impactful, and then kind of check and adjust. But with this fully modular system, it allows that, just fitting that player to their unique swing profile for how they deliver the club to the ball. It goes so far beyond what's been able to happen, in the past.
Well, I think that gives a pretty good insight into what the brand's about and what the products do. We have them in studio. We'll be getting that faceplate in to test out pretty soon. And whatever comes out of Bruce's mind in the meantime as well. But really appreciate the time. It's great to get such a great explanation of the product. Do come in and test it. It's, whilst it may be a little different, the results are a little different in a good way. So trust the results and trust that actually this is designed for function rather than just to look conventional. So thanks for the time. It's great. We'll be doing another bit on the putter soon.
Appreciate it.
But as I say, come and test it out. You'll be pleasantly surprised.